In the last lecture, we talked of vectors and scalars. These are the two kinds of quantities we come across in physics. Scalars, as I told you, have only magnitude. Vectors, on the other hand, have both magnitude as well as direction. And I also told you that two vectors are equal if they are parallel and they have the same magnitude. And I also emphasized that vector is a very important concept, and therefore, you must learn this concept well to be able to understand physics now and even later. In this lecture, we will deal with addition of vectors. Vectors, how to add vectors. But before that, a word of caution. Only vectors of the same kind can be added. For example, two forces can be added, two velocities can be added, but a force and velocity cannot be added. That means, the vectors to be added must have the same kind. Now, suppose A and B are two vectors to be added. You can see vector B here and vector A here. Do not be surprised that I am asking you to add two vectors which are not joined, they are at different places. You will come across in physics many times that vectors are not in the same place at the same point, and yet you are required to add them. So, here I have taken the example of adding a vector A to vector B. Recall that the arrow is called the tip or the head of the vector, and the other side is called the tail of the vector. So, when I want to add two vectors, I place the tail of the one vector at the head of the other vector. Let us take, I will show you this with a simple manipulation. This is vector A, you can recognize it. It is parallel to A that I have shown, and it has the same magnitude. So, it is vector A. I want to add vector B to it. So, what do? I place the tail of the vector B at the tip of the vector A here, and now I draw a line or a vector between the tail of vector A and the tip of vector B. See, this is called the sum of two vectors A plus B. You can add B to A and you can show vector A plus B is equal to vector B plus A. That means, vector addition is commutative. The order does not matter, whether you add A to B or whether you add B to A does not matter. So, vector addition is commutative in its property. I can similarly add more than two vectors. I have taken here three vectors A, B and C, and now I will show you how I am going to add A, B and C. Look at this. This is vector B. I have taken B first. I told you in the last slide that it does not matter whether you take B first or A first. So, I take B and then I take C. Notice that the tail of C is at the tip of B, and now I draw a vector from the tail of B to the tip of C here, that is vector B plus C, and now I want to add A. So, let me draw vector A, and I want to add B plus C to A. So, I have placed A, the tail of A at the tip of B plus C, and I now draw a vector from the tail of B plus C to the tip of A. See, this is the sum of three vectors A plus B plus C. You can carry on this process by changing the order. I added B plus C first, you can add A plus B first, and you will see that it makes no difference. The end result here is the same. The two vectors here, they are the end vectors or the result of addition of three vectors, they are equal, they are parallel and they have the same magnitude. Therefore, the vector addition is said to be associative, that is A plus B plus C is equal to A plus B plus C. The order does not matter. You can extend the addition to four vectors I have shown here. You see, I have added A to B to get A plus B, and then I have added C to get A plus B plus C. Then I have added D to A plus B plus C to get the vector A plus B plus C plus D. As I have said earlier, order does not matter, you can do in many different ways, but the end result would always be the same. Recall that in mathematics, subtraction of one number from the other, say 5 from 6, is actually the addition of minus 5 to 6. Similarly, here when I want to subtract vector B from A, I add minus B to A. You see, let me repeat, subtraction of two vectors is actually the addition of one and the negative of the other. So, let us see how we get the result. So, we follow the procedure of addition of two vectors, because subtraction is nothing but addition. So, we draw vectors, we take vectors A and B as before, and I want to subtract B from A. That means, I want to add minus B to A. Is this clear? That I add minus B to A. That means, I am subtracting B from A. So, let me start the process. Here you take vector A and vector B is already drawn. So, now I will take vector minus B. How do I get vector minus B? I draw a vector in the opposite direction and which has the same magnitude. So, I will draw vector minus B, and now I add A to minus B. That means, I draw the vector from the tail of A to the tip of minus B. Here it is. So, that is the subtraction of vectors. Subtraction of vectors is equivalent to addition with one vector carrying a negative sign. So, subtraction of B from A is addition of minus B to A, and we follow the procedure of addition. Let me repeat this once again. We have two vectors A and B. I want to subtract B from A. That means, I want to add minus B to A. So, I shall draw A, I shall draw minus B, and then add A and minus B. Here it is. So, A minus B is actually equal to A plus minus B, and you can see in this case the A minus B is not equal to B minus A. As in addition we had A plus B equal to B plus A, in subtraction we do not have A minus B equal to B minus A. Now, addition of two vectors can be done by a law which is called parallelogram of vector addition, and the addition of two vectors or the sum of two vectors is, say, vector A and B, A plus B, is called the resultant of A and B. Let us see how we can find the resultant. Here I have got vector A, I have got vector B, and I added A to B to get this vector A plus B, represented by a green line. Do you realize that it is actually the diagonal of a parallelogram which has sides A and B, vectors A and B? You can see I draw A here, I draw B here, and this becomes a parallelogram, and this vector A plus B, or the resultant of A and B, is the diagonal of the parallelogram. That is why it is called the parallelogram law of addition of vectors. Let A and B be two vectors and theta be the angle between them, shown here. You see, this is A, this is B, and this angle theta is the angle between them. Then make a parallelogram as shown here. So, I will draw a side parallel to B and a side parallel to A and complete the parallelogram. So, we have A here, B here, and B here. And now, with a little bit of geometry, we shall be able to show that the magnitude of the resultant is the square root of a square plus b square plus 2ab times cos theta, and tan alpha, alpha gives the direction of the resultant, tan alpha is equal to b sin theta by a plus b cos theta. If you know a little bit of trigonometry, you can do it easily. Let me repeat that again, that we have vector b here, vector a here, we complete the parallelogram, we find the resultant a plus b, draw up a perpendicular from r on the base, that is PQ, extend it to T. This angle is theta because it is corresponding angle, and this angle is alpha of course. And now a little bit of trigonometry would show that r square is equal to a square plus b square plus 2ab cos theta. The magnitude of the vector r, that is the resultant, is a square plus b square plus 2ab cos theta, square root of that. So, let me repeat this parallelogram law of addition of vectors. We have vector a, then we have vector b, we complete the parallelogram by drawing the vector b here and vector a there on the top, and then the vector from p to r is the resultant or the sum of vectors a and b. And then to complete this construction, we draw a perpendicular from r onto the base r t and extend p q to t. And now we can make simple calculation, it is not difficult, and you will get the magnitude of the vector r equal to a square plus b square plus 2ab cos theta. A simple trigonometry would give you this result, and the direction of the resultant, that is angle alpha, is given by tan alpha equal to r t by p q plus q t. It is b sin theta divided by a plus b cos theta. Remember that here a and b are the magnitudes of the vectors a and b, and the earlier result where we get the magnitude of the resultant, again a and b under the under root sign, they are magnitudes of the vectors a and b. There are some special cases of this result. You can see easily what would happen if the two vectors are parallel. Since the angle between them is 0, their cos theta would be 1, and we will have a square plus b square plus 2ab under root, which is nothing but a plus b. So, when two vectors are parallel, then the sum of these two vectors is just the vector which has magnitude equal to a plus b, and the direction is the same. Here, when two vectors are parallel, the angle between them is 0. Use the expression for the magnitude and the direction of the resultant. You know the formulae which I showed you earlier, these magnitude of the resultant and the direction of the resultant, and use these formulae and you will see that the magnitude of the resultant is equal to the sum of the two resultants, and alpha is 0. That means the resultant is in the same direction as the two vectors as shown here. You have vectors a and b, when you add them, then the sum has a magnitude which is equal to the sum of magnitudes a and b. So, when vectors are parallel, you get the result that the resultant vector is equal to the sum of two vectors. Now, if the two vectors are anti-parallel, then what happens? If you go back to the result of parallel vectors, you can guess what is going to happen. If the two vectors are equal in magnitude and they are in the anti-parallel directions, then the result is going to be a vector whose magnitude is 0. It is called a null vector. So, if the vectors are anti-parallel, the magnitude of the resultant is the difference of the two magnitudes, and if the two magnitudes are equal, then the difference is 0, and the direction is the same as that of the vector of larger magnitude. If the two vectors are different in magnitude, then the result that you get would be a vector whose magnitude will be the difference of the two vectors, magnitudes of two vectors, and the direction of the vector which has a larger magnitude. Here we have got two vectors a and b, and you know a is larger than b in magnitude. So, I am going to subtract b from a. Let us see how we do it. On this side I have vector A, and you see this is vector B, and the difference is vector A minus vector B, and the direction of the difference vector is the same as that of vector A. The direction is the same as that of vector with larger magnitude. And let me repeat, if the two have the same magnitude, then their resultant is a null vector, a vector having 0 magnitude. If the two vectors A and B are perpendicular, then again simple geometry would tell you that the magnitude of the resultant vector is the square root of A squared plus B square, where A and B are the magnitudes of vectors A and B, and the direction is along the diagonal of the rectangle with the two vectors as sides, as shown here, vector A, vector B, and the resultant is the diagonal of the rectangle which we made with vectors A and vectors B. In the next lecture, we shall take the multiplication of vectors, multiplication of a vector by a scalar, multiplication of a vector by another vector, and then we shall also see in the later lectures how a vector can be resolved into its components along a given axis, set of axes, and then we will introduce unit vectors.